Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSC, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. This series of lectures cover about mobile and pervasive computing. The lecture series cover cellular wireless networks, global system for mobile communication, GSM architecture, GSM protocols, connection establishment, frequency allocation in GSM network, GSM handover, security in GSM, and the general packet radio service, that is GPRS. The outline or content of today's lecture is about Equipment Identity Register, that is EIR, medium access control in GSM, GSM radio interface, and GSM protocol architecture. In the previous lectures, we have discussed about the various components in the GSM network. This is the functional architecture of the entire GSM network. It includes radio subsystem and network subsystem, operation subsystem. So here various objects are interconnected to form the entire GSM network. In the previous lectures we have learned about base station controller and radio cell and BSS, cellular towers, mobile switching centers, and various kind of databases and high speed switches and all. So today we are going to learn about the EIR, that is the Equipment Identity Register. We will learn it now. Equipment Identity Register is a kind of database. It stores some information about the user's mobile station. So why should we have the EIR register and what are all the advantages of maintaining this register? Let us learn it now. So individual mobile stations are identified by their IMEI number, that is an unique number. It is unique throughout the world and it identifies the individual user's mobile station. So now the EIR is a database that stores the IMEI number for all the mobile users. One fact about the mobile station is it is very easily exposed or it can be easily stolen. So how to manage that kind of situation? So now EIR will help us to manage these kind of situations. The EIR register now helps to block the stolen mobiles, so that we will learn now. Equipment identity registers help the mobile station users as well as the service providers in various kind of issues. We assume that the moment we miss the mobile phone, we are making the complaints immediately to the service providers and they are blocking that particular kind of mobile stations using the IMEI number. But what is happening actually? Stolen mobiles are stored and they are referred as the blacklist mobiles, but unfortunately the blacklist of all kind of service providers are not synchronized. So immediately we cannot block the mobile station once it is theft. So this is the very drawback of missing the synchronization part. So illegal use of the particular mobile station is possible. So, if a mobile station of the GSM network SIM belongs to Airtel is missed, so that person can buy the SIM card from some other network and still the mobile station can be used. So, the IME number should be used and the particular mobile should be blocked. That is the main aim and objective of developing that EAR register. So, based on the discussions, now we can conclude one thing. The EAR has three type of listers. First one is blacklist, and second one is white list, and the third one is grey list. Now, the blacklist is a list of stolen or locked devices. So, after receiving the complaint from the mobile users, the particular mobile station will be blocked. And white list is the valid mobile stations, and the grey list. In some situations, some malfunctioning mobile stations can be used inside of the country. So, that kind of malfunctioning mobile stations can be blocked using the grey list. So, almost we have discussed all the components of the GSM network. Now, we will start our discussion about the medium access control. So, medium access control says that how to share the medium. So, medium access control is referred as MAC layer. Now, MAC layer is a layer which specifies how the mobile stations to access the medium, because we know that radio users, that is the users, they are in roaming, they are connected with a cell phone tower. Now, many number of users can be connected to a single tower. So, now they should be regulated using some rules. So, MAC specifies that kind of rules. So, we can compare the MAC layer or MAC protocol of the GSM with the traffic rules and all. In the traffic or road transportation, we are following some signals and all. So, to avoid accident and to maintain the traffic clearly, we are using the signal systems. So, like that, the GSM network also specifies the MAC protocols to provide the better communication. Actually, MAC is implemented in the layer 2, that is the data link layer of the GSM network. The MAC protocols, the major classification of MAC about the GSM context is classified into three types, that is SDMA, space division multiple access, frequency division multiple access, and time division multiple access. In general, we have the fourth category also, that is referred as code division multiple access, but that is not listed here as the GSM is not dealt with the code division multiple access. Let us learn about the space division multiple access. Space division multiple access allocates separate space to the users in wireless networks. So, we know that the users are connected with the network through the air medium. Now, you have to specify the space or region through which the users can access the GSM service. Space division multiple access mechanism assigns optimal base station to a mobile user. What is an optimal base station? A particular user may receive the signals from many number of base stations. Now, it is the duty of the SDM algorithm to choose the best optimal base station, and it allocates that optimal base station to the user. So, now MAC algorithm decides which base station is good in terms of signal strength and available communication channel and all. So, based on that it will decide, and that particular kind of base station will be assigned to the individual user. MAC layer of GSM, that uses SDMA, considers the available frequencies, available time slots. So, it will take the correct decision. And one more fact is SDMA is not merely used, it has to be mixed or merged with some other MAC division mechanisms. So, SDMA is used with the TDMA and FDMA, that we will learn now. So, SDMA algorithm is implemented actually using the sectorized antenna. For example, a particular antenna will cover a particular region and another one antenna may cover another one region, so that you are dividing the space and we are providing the access to the mobile users. So, K1, K2, K3 up to K6, these are the channels. Now, individual channels can be assigned with the individual space. So, S1 is space 1, now space 1 is assigned with the K1 and space 2 is assigned with the channel K2. Like that we can have many type of spaces for many kind of channels, depends on the applications. So, this is what the channels are assigned with the individual space. So the next one is FDMA, that is frequency division multiple access. Here we are dividing the frequency band to several number of channels, and we are assigning that individual frequency channels to the individual users. So that allocation may be fixed. For example, if we consider the radio stations, the particular frequency will be allocated for a particular radio channel throughout the period. In some situations, we can assign the channels dynamically. So based on the demand from the users, that channel can be assigned. Frequency division multiple access can be used in the pure form, that is the frequency channels will be splitted and it will be assigned to the individual users, or it can be mixed with the time division multiple access also, that we will learn now. This diagram helps us to understand about the FDMA. Now K1 to K6 are the channels. Now x axis contains the frequency band. Now the frequency band is divided into many number of channels. So this is channel 1, this is channel 2, this is channel 3. So this diagram is about the pure form of FDMA, as the time is not splitted. So K1 is allocated with the first channel, K2 is allocated with the second channel, likewise. Now the K1 channel uses the entire frequency allocated throughout the entire time. So time is not divided. So this is known as the pure form of FDMA. So next MAC accessing mechanism is known as TDMA, that is time division multiple access. Here the time is splitted. So we have some set of frequencies and the users are provided with the entire frequency band, but the time is now sliced. TDMA allocates the entire frequency for the users through the time slots. So the whole bandwidth of a particular frequency is allocated for a channel based on the time slots. Now this diagram explains about the pure form of time division multiple access. Now K1 to K6 are the channels, and now the timeline is sliced. So the entire frequency spectrum is allocated to the individual channels with the various time slots. So at the first time slot T1, the channel will be used by the first channel, and during the second time slot K2 will use the entire frequency. So this is about the TDMA. GSMA mixes FDMA and TDMA. So in the diagram we can understand that K1 to K6 are the channels. Now both the frequency line as well as time line are splitted. So FDMA and TDMA are combinedly used by the GSM channels. So certain frequency band is allocated for a particular user for certain amount of time. So time and frequency lines are splitted. Let us have a short break. After the break we shall continue our discussion. Welcome back. So far we have discussed the various kind of medium access mechanisms in GSM. Now let us start our discussion from the radio interface of GSM network. Radio interface, that is the UM interface, is very important. This comprises many mechanisms to say how the wireless mobile users are connected with the GSM backbone network. So GSM actually implements the SDMA using cells. So cells are formed by the sectorized antenna, and individual mobile users are allocated with the individual BTS. So this is the functional architecture of GSM. The BSS forms the radio part. So various kind of BTS are used. These BTS forms the radio coverage. Now these radio coverages are used to connect the MS, that is the mobile stations, with the towers. So UM is the radio interface. So GSM medium access control mixes TDMA and FDMA. Now GSM 1800 standard uses 374 channels, and GSM 900 uses 124 channels, and each channel has the capability of carrying the signal with the 200 kilohertz of bandwidth. So far we have discussed about entire GSM architecture and its radio interface. Now let us start our discussion about the GSM protocol architecture. So protocol is nothing but the rules and regulations, how to connect the mobile users with the network, how to route the calls from other networks to the GSM users. So GSM protocol architecture includes signaling protocols, interfaces between many entities of the GSM. So especially interface is highlighted here as it provides the interface between wireless mobile user and a fixed network. So in the protocol architecture we have other interfaces also. They are A interface, A bis interface and O interface. Now we will fit all kind of interfaces with the right location in the GSM network. This is the overall view about the entire GSM protocol architecture. The protocol architecture contains radio layer, data link layer, radio resource management layer, mobility management layer and call management layer. So these all layers are managing the MS mobile station. Now this mobile station is connected with the tower, that is the BTS, through the interface. So in the diagram we can understand one thing, the entire mobile station is connected with the GSM network through the interface. Now this interface connects mobile station with the network. Now ABIS is the interface that connects the tower with the base station controller. We already learned that a particular BSC can control many BTS. Now ABIS is used to connect the individual BTS to the base station controller. In BTS we have some set of protocols, radio protocol, pulse code modulation and data link protocol, radio resource management subset that we will learn one by one. So this is the BSC part, that is basic station controller part. Here we have pulse code modulation and standard signal number 7 and BS SAP. So this is the last part, that is mobile switching center. Now this mobile switching center is connected with the base station controller through the A interface. So we will learn all the protocols one by one now. So radio layer, already we have discussed about the radio interfaces. So this is the kind of physical layer that handles all kind of radio specific functions. It includes data transmission. Generally we used to learn about the bursts. Burst is nothing but a small piece of information. Now multiplexing of bursts into the TDMA frame is done by the physical layer, that is the radio layer. Synchronization with the BTS. Many mobile users are connected with the BTS. Now the radio layer takes the responsibility of connecting the mobile stations to the particular tower. It detects the idle channels. Before allocating the calls and channels, the channels which are idle to be detected, so radio layer detects the idle channels. And before establishing the call, the channel's quality should be measured. Now radio layer measures the channel quality. So the data transmission should ensure the security. So encryption and decryption methods are implemented in the radio layer. But the radio layer ensures the data transmission with the security only between the mobile station to the BSS, not in between the other networks. So synchronization includes the correction of individual path delay between mobile stations and the cellular towers. A mobile station signal may reach the particular tower through many paths, so that path delay should be corrected. And as already we have discussed, many mobile stations are connected with a single tower. So all the mobile stations are to be clearly synchronized with the tower. So now radio layer performs that synchronization. Channel encoding, error detection and correction, these are all the main tasks of the physical layer, that is a radio layer. And one very important aspect about the radio layer is it supports FEC, that is forward error correction mechanism. Forward error correction adds redundancy to the data. If a particular data is lost, we have to recover that lost data. So as FEC adds the redundancy to the data transmission, it is very easy to recover the lost data. GSM radio layer or physical layer tries to correct the errors. The errors can be easily corrected, and GSM ensures that the erroneous data are not delivered to the higher level layers. Voice activity detection, it is VAD. Radio layer supports the VAD function. As all of us know, the voice communication is the major objective for any GSM network. Now GSM provides a void function. What is actually a void? During the silent time, the channel should be effectively used. So voice is the main service in GSM. So physical layer contains the special function VAD. VAD transmits voice only when there is a voice signal. Even a call is in progress, the user will not speak continuously. So during even a certain amount of very small or fraction of time, if the channel is not utilized, that should be preserved. So VAD transmits the voice only when there is a voice signal. So this mechanism helps to decrease the interferences. So if the channels are kept idle, there is no chance of getting interferences. So VAD of the GSM ensures the mechanism to reduce the interferences between the channels. But theoretically we assume that 60% of the time the user is idle, but in some extraordinary cases this ratio may be keep on changing. So we learned about the radio layer of the GSM architecture. Let us start our learning from the next layer in the GSM protocol architecture, that is link access protocol, that is shortly known as LAPDM. So LAPDM stands for, this is an interface between the mobile users and the tower. The protocol offers reliable data transfer over the connections, resequencing of data frames and flow control. So reliable data transfer, if the data is lost, the lost data should be recovered. So now this layer takes care about the lost data. And resequencing of data, sometimes the data frames may be transmitted in out of sequence. So in these kind of situations, the out of sequence packets are to be arranged at the receiver side. So now LAPDM do all the resequencing operations and flow control. We cannot expect that both the sender and receiver to be in the same speed. So that flow should be controlled. The source should not generate too much of packets and it should overload the client. So like that the flow control is maintained by the LAPDM layer. So it performs segmentation and reassembly of data. So sometimes a particular link may be capable of transmitting only a small kind of data. So in these kind of situations, the larger packets are to be fragmented or segmented. So segmentation is done by this layer. So segmented packets are to be reassembled at the receiver side. And one more important aspect is acknowledgement. If the data is delivered successfully, that successfully received data should be acknowledged to the sender. So the sender ensures that all the data are transmitted without loss. So that kind of data acknowledgement is supported in the layer. The next layer in the GSM protocol architecture is RR layer, that is known as radio resource management. From the name itself we can understand that we have to manage the radio resource. So the radio or the frequencies are the scarce resource that should be managed properly. This is implemented in the layer 3, that is the network layer of the architecture. It has many sub layers. First one is radio resource management or RR layer. So the lowest layer is RR layer. It has some specific functionalities in the GSM network. In the RR layer we have RR dash or RR subpart layer. So if we look at the diagram, we have RR layer as well as RR dash layer. It says that some functionalities of the radio resource management layers are bundled in the base station itself. A part of the radio resource management layer is kept with the base station and some part is kept with the base station controller. Base station controller management, that is BTSM, is utilizing this radio resource management layer. So let us learn about the main tasks of the radio resource management layer. It supports setup of the calls, maintenance of the calls and releasing the radio signals. The calls has to be set up, that is the frequencies are to be allocated, and after allocating the frequencies to the channels, it has to be maintained. The call should not be interrupted, and after once the call is over, that channel should be recollected. So like that the radio channel should be properly managed. The RR layer has the direct access to the physical layer. So RR is implemented in the network layer, but it has the direct access mechanism to the physical layer. So physical layer is nothing but the radio layer. Now the radio layer will measure the channel strength and all. So it will send the information to the radio resource management layer. So based on the report generated by the physical layer, now the network layer will take some decision. So this is the interoperability between the RR layer and the actual radio layer, that is a physical layer. RR also provides a reliable communication. Individual layers, they have the individual reliable data transmission mechanism. RR layer ensures the reliable data transmission to its higher layer. So, individual layers has to do some security mechanisms, as well as they should provide the reliable data transmission to the higher layer protocols. Let us summarize what we have learned in the section. So far we have discussed various kind of protocols in the GSM architecture, that includes RR layer and radio layer, LIPD, that is link access protocol layer. Equipment identity register is available in the OSS part, that handles all type of grey list, black list and white list of mobile stations, and medium access control regulates the access to the medium. Space division multiple access algorithm is formed by the cells and sectorized antennas. FDMA and TDMA are combinedly used by the GSM network. Radio layer do all the radio specific functions. It manages the allocation of channels, maintenance of the channels and releasing of the channels. LIPD, that is link access protocol, offers the reliable data transfer over the connections. It segments the packets, it resequences the packets, it provides the security and flow control mechanism. And radio resource protocol, that is RR protocol, is used to set up the calls, maintain the calls and release of the radio channels. Let us post some questions for our understanding from the previous discussions. How does equipment identity register helps the GSM network? Why GSM combines FDMA and TDMA? Identify the interface that connects MS with the GSM backbone network. How does the radio layer handle the erroneous data? What is the advantage of voice activity detection, that is VAD? With this we conclude today's lecture. The remaining protocols of GSM will be discussed in the forthcoming lectures. Thank you.